Hi, welcome to Engineering 160A, Studio Session 2.2, Array Indicators and Debugging Basics. Our tutorial objectives are we're going to discuss the use of array indicators to display numerical data which may supplement graphical data representation. We're also going to discuss basic features in LabVIEW which can be used to aid in debugging a VI. To achieve these tasks, we will modify our code which we created in Studio Session 2.1, the for loop and waveform graph. In our previous tutorial, we used a for loop to calculate the sine function 100 different times, build an array, and then graph it using a waveform graph. And here we can see our sine wave, which includes 100 points. Let's say we, instead of having to read off the values or interpolate the values of our sine function by reading off our axes here, we wanted the user to be able to see the data to a higher number of significant digits. Well, a better way to represent the sine wave then may be by using an array indicator. First, we will look at a detailed, more thorough development of an array indicator, and then I will show you how we can quickly create one within the block diagram. From our front panel, let's right-click to bring up our controls palette. Then under Modern, we have Array, Matrix, and Cluster. The first function here is the array shell, so let's grab that and drop that down into our front panel. Inside of our shell, we can turn this array shell into either an indicator or a control. So we want to display or create an indicator. So let's go back down to our controls palette, go down to our numeric palette, subpalette, and let's go to numeric indicator. Then we can grab it and drop that into our array shell. And now we have built an array indicator. We need to hook up our array indicator, so let's double click on our front panel, and that will bring us to where it's located on our block diagram. And let me then drag it around. And what I want to do is just output the array into this indicator. So let's recall this thick orange line is our array. So let me hover over the wire to create a new wire and input that into my array indicator. Now if I rerun the program, in addition to the values being displayed on the waveform graph, I will also have an array displayed which has 100 different elements. Let's try this. I'll first delete the data, right-click, Data Operations, Clear Graph. And now I will rerun the program. And when I do that, I see I generate my waveform, and now I have an array where the first element, or the 0th element, of the array has a value of 0, and I can check the other values in the array by just clicking up or down on this arrow here. So our first element has a value of 0.198, 0.89 for the second element, and this will keep going up all the way to a value of 99, or the last element, because again we have 100 different elements which are indexed 0 through 99. If I try and go up to 100, you'll see that the value here gets grayed out, indicating that there is not a 100th element. If I wanted to see more than one of the elements at a time, all I need to do is, let me go back to my 0th element, which is 0. I can drag down here and increase the size of my array, and I can see more of the values at a given time. And of course I can drag this to be whatever size I want. I can make it even display all 100 elements. If I now increase the value in this indicator, all it's going to do is make the first element that's displayed the first element in the array, then this is the second element, and the third, so on and so forth. Let's now look at the easier way to create an array indicator. We can also simply hover over an array wire, right-click, and then go down to Create and create Indicator. This will create a numeric indicator similar to what we had previously. Let me erase the array I just created, and then hit Control B to eliminate all broken wires. Let's spend a few moments talking about debugging of VI. Well, let's modify our block diagram to change the way it operates and see if we can cause an issue. Well, one way which we can do this is if we recall that our waveform graph and our array indicator both need an array as inputs. If we were to send into these function blocks just one single number and not an array, an error will develop. Well, one way in which we can do that is we can change our tunnel mode coming out of our for loop from being indexing or creating and storing all of the calculations from every step in the for loop to just outputting the last value. And once we do that, we notice that all the wires that went into my waveform graph and went into my array indicator have now become broken. When there's an issue in LabVIEW and the program can't operate, what you'll notice is that the icon, which was the run button, has now become a broken arrow and it says list errors. So we can left click on this and it brings up a dialog box of all of the different errors that exist in the program and gives you a description to help you try and figure out how to fix it. So it says there are 2 errors and warnings, and we have you have connected 2 terminals of different types. We have a number leaving our tunnel and trying to go into indicators, graphical, and an array indicator, which need an array as the input. So I can double click on one of the errors and it will highlight to me on the block diagram where it occurs. I can also click on the second error and it will highlight where that error is occurring. Let's go ahead and fix these errors by just again changing my tunnel mode, and instead of being last value going to indexing. Now you see all of my errors and warnings have disappeared and I now again have my run button. Another useful debugging tool in LabVIEW is the probe feature. What the probe feature does is it allows me to look at the value that's going through any wire I choose in real time as the program is operating. In order to create one, all I need to do is hover over a wire, right click on it, and then go down to probe. And when I select that, you'll see there's a little number 1 that is placed on that wire, and then I have this probe which will give the value in that wire when the program is running. So I have hooked up my probe to the array, and now if I run the program, we can see that inside this probe it gives me all the values of that array. So I can now have my probe display, and I can also look at the values in that wire similarly to the array indicator which we placed on our front panel. I am by no means limited to just one probe. In any given VI, I can have many probes which could be useful in helping me debug a program. The last debugging feature that we want to discuss now is the highlight execution button, which is denoted by this light bulb. What the highlight execution button does is it makes the program slowly step through each step. And while it slowly steps through, it shows and indicates you the flow of data and also gives the intermediate values throughout the process. So to highlight how this works, let me create another probe on the iteration number. So let me right click on the wire, create a probe, and that is probe number 2 here. So also for demonstration purposes, let me limit the number of times that I'm stepping through my for loop. Instead of having to go through this program or this for loop 100 times, let me speed up the program by having it go through 10 times instead. Now when I have my highlight execution button turned on, the light bulb will become illuminated, and when I run the program, what I want to do is take a look at the probe number 2, and you will see that it will slowly step through the for loop and it will indicate to you what step in the loop it is on. First time through, you'll see it has a value of 0, then 2, then 3, all the way up to 10. Once it has gone through all 10 steps of the for loop, you will then see the data exit the for loop and be sent to the waveform graph and to the array indicator. So let's begin. Okay. We see the calculation happen. We had the sign of 0 the first time through, second time through, 0.2, then 0.39, 0.56. If I look at my probe, we see we're at the 5th, 6th, now 7th time through, and we're trying to do this 10 times. And once we get to the 10th step, you saw the data leave, go into my array indicator, and also into my waveform graph. And that concludes our tutorial on array indicators and debugging basics.